Venkat sir and Ranga sir, one request from my side.
Yes, madam.
I want to take snapshot so that
Sure. What snapshot you want? There are different types of snapshot. You want a snapshot of my photo, or Ranga photo, or the whole participants? Either way.
no, then and there I'm taking from day one, sir, all the snaps. So
Okay,
today I
cool.
would like to take you both individually,
No
so
problem.
that if you are visible to me, then I'll pin you and take it.
Okay, fine. So is this better now? Action ready, and then we'll give it to Ranga also. I'll open the PPT. So with that you can have. Yeah. Are you seeing my PPT now?
Yes, sir. Yes, sir. I can able to see.
Okay. Let's get going. There are a lot to cover in the afternoon session, and then we also have a recap. So I will try my best to brief everything and also show some practical example of MongoDB, depending on how time goes. Okay. So basically, in all these 4.5 days, you've been talking about three things, and right, AI, data mining, statistics, machine learning, text mining, NLP, etc., etc. What is that for us, and what are the latest trends? What are the opportunities in the research, and what are the jobs and skills? And then I will also continue about the big data, and I have Hadoop, and then MongoDB, right? So you see this, everything again coming into Industry 4.0. In the very beginning, I talked about Industry 4.0, 5.0. The same thing now again I'm talking, right, on Industry 4.0. If you take Industry 4.0, Industry 4.0 is everywhere. One classic example, where is the trend going? Where is the world is going? Like say subscription on demand, where Industry 4.0 plays a role. When I say Industry 4.0, everything is going to work together, meaning IoT, machine learning, data mining, cyber physical system. By the way, Mr. Ranganath is very, highly, having high expertise in cyber physical systems and security. In fact, he is also undergoing one special master's degree in cyber security. So even Vijay Bharat and myself, we used to handle network security and all. So there's a cyber physical system. The trend, how secure, we are talking about one of the person in the morning, we asked a question to Vijay Bharat, how to handle the security and things like that. So when you talk about Industry 4.0, we talk about IoT, we talk about AI, bringing the machine intelligence, and then bringing the cyber physical system and using the big data. These four are the buzzword. So if you look at all our cloud, of course. So cloud, big data, machine intelligence, AI, data mining, IoT. These five are the basic building blocks. Of course, on top of that, you have a cyber physical system. So these are all put together, used for Industry 4.0, Industry 5.0, right? So if you look at it, virtual reality, curated content, right? How the AI is going to play for the deep learning is going to look at the human computer collaboration, connected home. Homes are connected, like say the relatives' homes can be connected. If one home is there and another home, they can watch even though the persons are not there. They can do all those things. Next generation of out of home entertainment, VR adventures, and a lot of streaming. A lot of drones are going to be deployed in many things, right? And then gesture control. And similarly, like VR and augmented reality, where you have a lot of new works and projects are happening. Connected home, curated content, more of 3D and 4D, and then it's also going to be evolved more in the finance as well. In the financial also, like there are a lot of data, and then how are you going to look at data-driven approach, relooking, right? And that is what they are looking at it. How they are taking the finance nowadays. People are not even going to the bank. Everything is all done through online, and then so many online-based verification is done. So many, Paytm, they're doing Paytm, Google Pay, this Pay, that Pay, right? So a lot of things, and then even I can schedule agent to even buy the stock using this account on this particular date. If the stock price is going to be up, I don't have to sit in the computer system. I'll just give, as Ranga says, like voice. I can use a voice. I can say, I would like to order, pizza around 8 o'clock. That's all. It will automatically knows where I am. Am I at my Periya Veedu or Chinna Veedu or beach house or whatever? I'm just kidding. Okay. So where I am, accordingly, it will just trying to order the place and based on the date and time, etc. Right. And also, I would like to buy some stock of, or if that stock price is going to be up like this much, I wanted to buy, or if I wanted to, that stock price is going low, I wanted to close that stock. All those things can be configured, right? That type of level of the things it is going to go, right? So it's all going to be, still financial industry is struggling because of one term. It start with a letter bit, end with some currency. What is that? Anybody knows? I gave a clue. Any answers you are getting, Ranga, your favorite topic?
Yeah, they are saying Bitcoin.
Excellent. So now the governments are getting confused whether we go fully digital or, still people are looking for money, and then, how much we can go with the Bitcoin. There's a beautiful, Bitcoin we have done. Myself and Ranganath has given a extensive workshop for the MBA students in Acharya Nagarjuna University in Andhra Pradesh, wherein we cover a lot about Bitcoin and how you can use secure, even a normal life, how you can run a secure life, and how to secure your system. So that comes under the cyber physical systems, that primarily on how from management angle you can use the cyber physical system, from research angle how you can use a cyber physical system, right? So these are all some of the refinancing, recapitalization, acquisition, right? Asset-based lending in manufacturing, transaction finance, working capital solutions. There are so many areas are going to be, and in the automation industry, some mechanical engineering professors are there. It is going to evolve more of robots and machines. Do you see any human being? Here all machines are involved. Only human being is just configuring. I got a chance to visit a factory in Japan. I was a performance engineer. I went to improve the performance. I went to Intel factory and Samsung factory. Also went to Korea. That rooms are totally, with the robots and machines and all these unmanned vehicles. And then we used to only load. And I went there to configure the database and collect the statistics. That's the only thing we do, right? Apply the AI and data-driven technology, right? And VO Robotics, WOQTON, right? So they are building the open factory operating system, cloud-based platform, couples the design requirements, as I shown in the very beginning of the day, like a digital enterprise. So all value chain, that's going to happen. Automation everywhere, anywhere. Robotic process automation, that is a trend. We're talking about AI, what is going to be from mechanical industry. You can say that, robotic process automation. We all know about, you all studied control system. You all studied closed loop control system. You all studied about process automation. You studied about manufacturing execution system, MES, equipment, engineering systems, etc. Now we are going to talk about robotic process automation system. So the entire shop floor, the entire manufacturing site is totally managed by the robotics, right? So that's going to be there anytime, anywhere. Personal access, flexible delivery, peers and mentors. Why, where, not, what, how, practical application. Students' ownership from the education side, right? All those things are all going to happen. If you look at the healthcare, better service for patient, digitally controlled service. Services are completely digitally controlled. You go, suppose you want to take a blood test, right? Imagine it's going to happen like this. So basically, blood test, you fix an appointment. That's all. Automatically, like your inputs and all will go. When you go there, there will be a machine will be there. The machine will test your blood, and then your results will come into a text or SMS or WhatsApp into your system. So that type of digitally controlled services, and also doctor can give an instruction remotely using the cloud-based. I work as a consultant for a healthcare company wherein we have configured like a radiology systems and all those things. We can remotely monitor the patient health and all those things, and medical imaging, precise surgery. They started using robotic arm to do a surgery, IoT devices for patients, sensors to sense the diseases, right? So all those things are all going to evolve, right? Innovative service to a patient, recycling of medical waste, how best we can do the managing the waste, things like that, accurate information. So these are all some of the research areas. So if you want to pursue research in healthcare, tying up with Industry 4.0, what you got to do is go to internet, go to ACM, go to IEEE, go to elsewhere, go to any of the journal site and look for these things. Precise surgery, Industry 4.0, performance, evaluation. You use those words. You have to coin the words correctly. Then you will get tons and tons of paper. Then you can start working on it, right? And these are all. We'll share the slides with you, and how it is going to transform everything into digital. How to make it well-being, as I said, like a societal. So we wanted to not only for the machines. This is also human being. So we got to sustain well-being, collected data sets. It has to advise, it has to monitor, it has to support, treat, assess. All those things are all going to happen. So that is where the world is moving towards, right? So with respect to the jobs, myself and Ranganath is conducting assessments and all for the data engineer, data scientist. I'm working as a consultant for one US-based company, wherein they're replacing all their existing jobs and then taking as a data scientist and then data engineers, right? So now there are more jobs as a data scientist, data analyst, NLP expert. Ranga covered you a lot about NLP. There are opportunities as an NLP expert. You can tell all these things. You explain NLP to your student and then ask them to be prepared. The job, they are not going to ask Android developer. They are not going to ask C++ developer. There are tons of C++ developer. They may ask you NLP expert. PySpark specialist, recommender system engineer. We are covering about recommendation systems, how you use the recommendation, Amazon recommendations and reviews. You have seen that. Time series forecasting analyst, auto ML expert, RNN specialist, right? Because we have given an exposure to you what is RNN, you know what is RNN, right? And image processing / computer vision analyst. In Ramachandra, medical institution, deemed university, they're recruiting a lot of vision analysts, computer vision analysts, speech recognition engineers, chatbot engineer, drone developer, right? For working with a lot of IoT devices, IoT software developer, they're research analysts, robotic engineer, right? Data scientists, AI, radiology, and many more for the medical field. And starting salary itself starting with 6.5 lakhs. See this, in US, the IoT junior software developer is getting about 51,300 to 66,800. After I worked in Malaysia, after I worked in Singapore, when I went to US, I got this salary, around 66,000 US dollar. That even now a junior software developer, IoT developer can get. So that is the power of all this evolution of all this technology, right? And what are that? This is very, very important slide. If you want, you can take a shift to print screen. Madam, you can also take, Sudha ma'am, this you can submit as part of your, whatever things you wanted to submit to AICTE and right. So this is the basic thing. This is what we have been talking all along, all these 4.5 days, 5 days, right? If you want to become an expert in AI, machine learning, right? The future of jobs, right? They predicted almost 9 jobs, which will be trending by the year 2022.
Doctor, there is a question from Yogendra, madam. Is there any role for RF in these technologies? Radio frequency, madam?
Yes.
Tons of,
yeah.
IoT sensors and RF devices, they go hand in hand. There's a lot of opportunities.
Yeah, especially for the the space related projects, and then for the networks related projects, because they're all smart city. They are of course going to use. We worked on one paper. Probably if we have a time at the end of the day, myself and Ranganath and then one more gentleman, security expert, we worked on what you need to do for the smart city security. So we worked on a paper, a book chapter, international book chapter that is going to be published soon. Okay, so we will share that at the end, because the smart city involves a lot of frequencies, a lot of RFIDs, and then a lot of barcodes, a lot of mobile devices, right? So definitely, see, please pay attention here. There are 1, 2, 3, 4 contexts. Are you seeing it? I'll zoom if you want. We go one by one. See this? If you want to be an expert in AI, and machine learning. The old days are all gone. Old days are all gone. I know C, okay, I'll do C coding. I know Python, okay. See, when I'm doing consulting, I say I only know Oracle. Okay, so what? That's what there'll be an answer. So I have to work with Oracle, I have to work with SQL Server, I have to work with Oracle in cloud, I have to work with MariaDB, MySQL, MongoDB, and then all other databases. And only, and of course, apart from that, you should know how to do the automation. So the world is demanding so much, right? Even in the maths and statistics, machine learning, statistical modeling, experimental design, Bayesian inference. We have prepared one little, as per a request from Alirani ma'am. Yesterday, Alirani ma'am called me and spoke to me in length about some of the participants' feedback as well as some of the requirements, you know. So thanks for overwhelming response and encouraging words which you have shared with SASTRA, and we really appreciate it. So we are planning to conduct one session which will address more on the statistical part of the machine learning and then the future. How Ranga has already talked about gradient descent, right? And clustering, right? Dimensional reduction, which we did not cover, and we did not cover much about this logistic regression. Only we talked about a little bit of regressions, and we covered only decision tree, but we did not talk about random forest, right? That is the newest way the people are using it. But of course, you need to have a knowledge of decision tree. You should know what is Gini index. Next time when I talk about random forest, when Ranga talk about logistic regression, yes, you will sit like in Rajinikanth movie, Ajit movie comes, when they comes, you go to the, or your favorite star, Shah Rukh Khan or Amir Khan, you go to the front or Nayanthara. Okay, so for the boys I'm saying, okay, so you go to the front seat like that, you will come forward and start learning. So that, Bayesian inference, which we did not cover, you have to get expertise. Future, further, right?
One thing, Venkat, just there are questions coming up.
Yeah.
So also, Sudha madam is saying also in image processing, and Varsha madam is saying, which are the applications of brain signal analysis?
That's coming. Yeah, we are going to, yeah.
Correct. And also one request is, approach this with an open mind. Don't confine yourself to a specific area that you are aware of or you know of. And,
absolutely.
You should be in, gathering knowledge wise, you should try and gather as much as possible, and then you can apply it anywhere and everywhere. See, pretty much, as yesterday one of the participants was saying, sorry Venkat, just 2 minutes.
Sure.
All this, whatever we are doing, it's called as transfer learning. None of us are going to sit down and start writing the algorithm from the scratch. Nobody's going to write a knives-based algorithm again or a logistics regression. We need to understand how the basics work, what are the different ways of connecting things, and then we are just doing a transfer learning, and we're going to be applying. So it's wide open. Keep your eyes wide open, and just listen to this entire slide. Let him explain, and I'm sure almost 99% of your answers will be questions will be answered. Go ahead, Venkat.
Yeah. Thanks, Ranga. Okay. So once again, if I say that, I think participants may say, like, I wanted to hear yes from participants. How many of you learn machine learning as part of this 5 days workshop? Yes, or no.
1 yes, 2 yes, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15,
okay.
16. Okay, good yes.
Did you learn some modeling? What type of modeling Mr. Ranganath covered? Yes, covered one modeling. And I think Alirani ma'am also came and then, gave some inputs on during the modeling. You can model. You all researchers, right? We do a lot of mathematical modeling, right?
Revati madam says KNN.
Okay. Some more.
Decision tree, linear regression.
Y equal to mx plus c. Simple, linear equation expressing the, data into some models, right? But of course, there are a lot more. There are a lot more there in the modeling. Okay. And, we didn't much focus on how to, how to do an experiment. All of you, Ranga sir has given some data. I have given some data. With that data, Remember, I gave one data for the decision tree about how to do. This is kind of a recap also. After this, immediately I'll go to recap. That will be much better. And yes, Ranga, we can do that, right?
Yes, yes.
Yeah. Okay. So experiment design. Ranga has given some data, some cloud, and then you have done some prediction and reviews, right? So that is, you know how to, but you still did not get exposed with how to go by experiment design. That we have nicely prepared how to work with the data profiling, and also Bayesian inference we did not cover. And I hope how many of you learned about decision tree?
They already said.
Oh, good. Unsupervised learning, you heard about clustering. What thing you have studied in the clustering? Do you remember? Oops. What are the techniques you remember in the clustering? We have done one example also. Do you remember?
They say K means K median center clustering.
Excellent. Excellent. Yeah. And if you see that, we did not cover about dimensionality reduction. That comes under the PCA. Right. So that we have to go further, and even further gradient descent. Right. So this is one part of the max and statistic. There are a lot of hidden things inside. And looking at the programming and database, right? Yeah, one side you know all the statistics, models, etc. So what? I need to know how to work with that. I should know Python, right? How many of you can simply open the Python Anaconda, can do the coding without any fear? I want to see yes from the participants or no. Are you now scared of Python?
4, 5, 6, 7, 8.
That's all. Rest of that doesn't know Python.
11, 12 introductory level say Sampada. 7, 8, 14, 15. 16, 17.
Okay, cool. I think some of them are expert. They don't want to reveal their secret.
Yes.
Yeah. Another thing, you've seen Mr. Ranganath has explained you some R programming, how to work with R, but we did not train much on the R, right? So this could be something which you can learn. Not only from us, anybody. You can just go to any forum, any workshop which is teaching you R. Please do learn R. And then databases and SQL. We did not cover much. I'm going to explain, after this session, I'm going to give you a little bit about this SQL and NoSQL, right? And relational algebra, parallel query processing. And this I'm going to touch upon today, MapReduce concept. How the big data is going to deal with the MapReduce, Hadoop. These two, in another 10 minutes, I'll be explaining you MapReduce and Hadoop, how to reduce the custom reducers. SaaS like AWS, this we already gave you a demo and shown you the cloud working, and then Vijay Bharat has shown you AWS. Yes, right. And come to this domain knowledge. Domain knowledge and soft skills are very, very important. As I said, computer science is common sense. I learned from Ranga, right? So irrespective, this domain means any domain. Passionate about the business, right? Whether it is educational or manufacturing or whatever the field you are working on, you should be passionate, curious about the data. Data scientist, what the doctor will do, by looking at the data, he will start making a lot of questions. The moment you see data, you're going to be like a Curious George. There's a cartoon character called Curious George, right? Influence without authority. Hacker mindset, you have to go like a hacker mindset. What people will go, not real hacker, ethical hacker. Okay, problem solver. Strategic, proactive, creative, innovative, collaborative. This is how we say we need to be 3 mantras. What are those 3 mantras? 3 letters starting with the A. All the 3 words starting with the A.
Shoot it out. Come on, participants. Acquire, agile. Agile, acquire. Acquire, adopt. Adopt,
excellent.
acquire, agile.
Okay.
Hi, Milo.
Milo. Tanya.
Acquire, adopt, agile.
He's agile. Big data space. Just hold on 1 second. I'll send him from the room. மேல போ. தானியா செஷன் போயிட்டு இருக்கு தானியா. போய்க்கலாம் தானியா. அம்மா செஷன் போயிட்டு இருக்கு குறைச்சிட்டு இருக்கா மைலோ. அங்க யாரா வெளில இருக்காரா? அதுவும் முடிக்கிறோம். அவங்க அனுப்புறேன் வெளியில.
How to design? Not required, madam. How to design one machine learning algorithm, Varsha, madam? Let's not. We don't have to redesign the wheel. To use the existing algorithms and putting them to best use itself will take a lot of time. But to answer your question, if you are really good at math and you have a very good understanding on statistics, or if you want to work on deep learning algorithms, you are very good at those math, you can see the way research works is you can take, for example, Venkat has guided one of the research scholars on big data. You take existing products and develop on them. You can take a KNN algorithm and you can come up with your own version of algorithm. So just to give you an example, there is Euclidean distance, there is Manhattan distance, there is Mahanapolis distance. It's all distance, right? So you can improvise on that. You would rather spend your research time on a well-established algorithm or a distance learning mechanism, pick that up and try to work on it.
Either connect aitala idu sound.
No, sir.
Sorry. Milo. My dear Milo. Okay.
Sir. Mute change. Chandraga mute change. Go ahead. Yeah. So that is the answer, Varsha, madam. You can just start fine tuning and developing, existing. Take the algorithm that you're good at, go into the math basics, drill into it, and come up with a fantastic research. All the best. We are looking forward.
Yeah, other thing, like as I said, there are a lot of fields we talked about. One of the field which is going to grow more is research analyst. There will be a lot of jobs now turn up. That will be a good opportunity for academicians also to play a kind of a consultant role. A lot of projects may evolve. Research analysts for researching, analyzing. In US nowadays, they started, recruiting research analysts, right? So they will work on analyze the market, analyze the data, and provide the solution. That type of thing is happening now. So that is another field which is basically growing. Like say with the master's degree, if you are very good at research, they get up double $165,000 US. So that's where the world is going. What is that you need if you want to be a strong research analyst? So one of the person is asking a question, right? So you need to know how to deal with a large and complex data set using SPSS, SAS, Excel, Microsoft Office suite, also using relational databases. You should know how to perform the statistical analysis. So that is very, very important, and learn a lot of other tools. There is going to be one person was asking about signals and other things, even image analytics, signal processing, right? So wherein how you are reading the MRI, CT, ultrasound, X-ray, right? Looking at the data and then doing the data analysis, right? Those and all going to happen. See here, they are going to apply image analytics, deep learning, inverse problem in imaging, clinical decision, resource resolution, reconstruction. You need to have expertise in deep learning and computer vision, image processing, TensorFlow. You remember this? Keras. We already exposed you what is Keras, what is TensorFlow. These are all some of the the packages, famous packages, and basic understanding of medical imaging. Some skills in biology or biomedical will be very helpful. But end of the day, you need to be good at design, analysis, and implementation of algorithm. Right. That brought down to our topic of big data. So we've been hearing so many things about data.
One quick question, Venkat.
Yeah.
Professor Vikas, Varsha madam, I've answered your question. Those are the measuring parameters for errors. It was in one of the slides, remember? I showed you about root mean squared error. That is, those are the because professor is asking, can you put a light, sir? Tableau is more of a visualization tool, sir. Tableau is used more for data
Reporting.
visualization and reporting, and in with regards to the data science and AI, it is also being used to do in the data preparation cycle to view the how the data is laid out. Those are the things that you're looking at. And Ankur Rai is asking how EC students can prepare for IoT. What should they do for preparing this?
Should I address? You will address?
EC students can prepare for IoT. So basically what they should do is they should start reading a little bit of IoT, attending the sessions, and work on that simulator, and then grab an Arduino kit. It's about $450. They can start working on it. They will get all kinds of confidence. So once they start working on that Arduino, you can just go buy the basic Arduino kits. It's about 450 rupees available in Amazon, and they can come up with the small projects like turning on their light at their home, measuring the temperature. Those are the things that they should do to gain a little bit of confidence, Professor Ankur. Rag Ramya is asking how big data is useful in ECG signal processing.
Okay.
We'll address it after.
Once I explain all the big data, that she can answer the question instead of me answering the question. Once you're hearing that inputs, probably they themselves, the participant themselves, can answer the question. Okay. I will anyhow. I will try to address it. Okay.
So you can jump
when they go through, they will be able to get that. Okay. So
you can jump into the Banganapalli, Himam Pasand, all that mangoes now. This is actually Mango DB. You guys thought it's Mango DB, right? It's Mango DB. It's very tasty. Carry on.
Yeah. So a lot of data like smart city sensor model, social media. You already seen this earlier. So much of data is being generated, right? So now, do you think that all can be fit into one simple system, regular system? Again, that will, whatever I'm saying, please pay attention that you can relate to your questions, relate to your thoughts, right? You're talking about EEG signals, how many signals? In fact, some of the EC students came to me, and then they started collecting a lot of EEG signals at every 5 minutes or 10 minutes. They started finding, to look at that seizure prediction, right? So there's a lot of data, and you can take the data and then which data is having the spike and things like that. So to store the data, you need a big data environment. You can't use a regular DBMS, right? So you will see more. So lots and lots of data. Facebook handles 40 billion photos. Walmart handle more than 1 million customer transactions every year, right? Human genome, right? You say took 10 years, right? And see, that big data is a hot topic, right? It's like a buzzword. It's an umbrella term. It's an umbrella term, like cloud is an umbrella term talking about computing over the internet, computing and processing over the net, storing in the internet, right? Connecting multiple systems, right? And remotely, use. Same way, big data, because data is going to grow a lot, and from a different sources of data we are fetching in from social media, network, switches, RFID. So madam were asking, a lot of RFID, a lot of CRM data, ERP data, that is for the planning and everything, billing data, websites, lot of things are all going to generate different types of data. Do you see that? What does this signify? Shopping cart. Let me zoom this a little bit. Can you tell me what is this signify? 1, 2, 3, 4, 5, 6 signify. This is
e-commerce, video.
Yeah, e-commerce, market basket, right?
Music.
And then, this is internet, World Wide Web, social media, and this one is all email, text, communication. Lot of email, can be used to predict about the customer. Lot of images, lot of videos, streams, video streams.
Photos. Yeah, they're saying
lot of audios.
They are saying it, all of them.
Excellent. So big data is the latest buzzword, right? So by end of another 15-20 minutes, you will know what I'm talking about. You all know what is big data. Right. Types of data. So you have a different types of data which you have seen, right, in day-to-day life. You have seen relational data, lot of tables, transactions, legacy data, right? A lot of text data you might have seen in the internet. You're looking at the text data. There are a lot of semi-structured data. It is like XML, right? Extended markup language. You all know about HTML. Like say XML will be just a tag, customer, and then name, customer tag will be ending. Like HTML, it's like a HTML, but we have every tag will have a value. Then you have a lot of graphical data, social network, semantic web, right? So, and then you have a lot of streaming data, right? You can only scan the data once. You don't have to keep on scanning the data, right? So, having said that, the data is classified into three major types: structured, semi-structured, unstructured, right? And you have like semi-structured like the CSV file, XML file. We talked about the JSON file, right? The key value pair, right? And we have some documents, and and there are unstructured data like tweets, logs, web chats, YouTube streams, and things like that. And structured data like a regular data, transaction data, right? Now I need to find a way to put all these things in one place and should be able to manage that in a real time. Email messages, word processing document, videos, photos, audio files, presentation, web page. That's why you have this elephant here. Elephant takes so many things. Elephant can take so much of volume of data, right? That's where now you see two universes are the new reality: structured, unstructured. Structured, relational DB system. Unstructured, no relation. I don't want to store, because today he is a customer. Tomorrow he may be my wife, or tomorrow she may be she may be wife, or he may be my husband. We don't know. We don't judge that this customer may be today is Amazon customer. Tomorrow he may be a Walmart customer, Flipkart customer, right? So don't set any relationship. That relationship is gone in the NoSQL system. There is no need to say the employee works in a department. Come on, man. Which world you are talking about? A person can work in a company. A person can work in a consulting firm. Person can work in some temple. Person can work in some social service. Don't relate as one thing with one thing. That barrier is gone. That is the big thing, big steps towards unstructured data. Structured, known schema, without a schema. We don't come in, we don't constrain with one thing, right? And we
what is schema, participants? No, what schema is? Keep thinking, and you can continue. You can give me the answer on the chat.
Yeah. So 1, 2 is like say you say.
No, what schema is? Keep thinking, and you can continue. You can give me the answer on the chat.
Yeah. Yeah. So 1, 2 is like say you say HR, accounting, customers, like that, right? So anyway, ACID means atomicity, consistency, integrity, and durability. For simple example to explain what is ACID transaction, you are going to your ATM, withdrawing money of 5,000 rupees. While you are withdrawing, the machine is struck. Amount did not come out. Then what should happen? Do you think that the amount should be deducted or credited back?
Type in your answer.
Okay, so either you commit or you roll back. There is no half-boiled work. It is like a omelette with all, onion, chili, and everything. No half-boil. Okay, it is complete. Either Ishwara, no acid. Okay, transaction, no transaction, no atomicity here. So it can be a small unit of work, can be handled by one node. Here, if I commit, if I do a transaction, either if suppose in between something failed, it should roll back entire thing, and it should not spoil. It's just like that. I cannot go and then delete the employee. If I delete the employee, and then it should not delete the department. If I delete the department, it should not delete the some of the related department information. So that type of thing we are talking about. So here transaction, here no transaction. SQL, no SQL. rigid consistency model. Here, a little bit of eventual consistency model is there. ETL, we have to really do a lot of things. We have to model the data. If you want to go to relational database, I don't know how many computer science people are here. You got to do the modeling. Like mathematical modeling, you have to do a database modeling. You have to design the schema. You have to do a lot of things. For just the simple work, you got to build so many tables, so many entities, create relationship, create consent, blah, 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 blah. And then you have to extract the data, transform and load, prepare the data. Nothing of that sort in the unstructured systems. No ATL. Longer time to insight, faster time to insight, because this is going to be more of agile. I can just like that, I don't have to know the syntax. I just access, the record is created. You will see. I'll try to give an example. Otherwise, at least I'll play the video. Maturity, stability, efficiency. The main thing here is the flexibility, right? So this and all we have already seen. So unstructured data is exploding. Data is exploding, increasing like anything. So what do I do with this data? I got to do a lot of aggregation. I have to make sense out of it. I have to do statistics. I have to do search on something. I have to do some pattern matching. I have to do data mining. I have to do statistical modeling, right? Now coming to the characteristics of big data. Having said that, anybody ask you a question, what is big data? It is an umbrella term to handle large volume of data. The data can be of any type. It can be structured, semi-structured or unstructured. And it can handle any type of data without rigid relation. So big data is a platform. Hadoop is a platform, right? And there are a lot of big data platforms are all there. And MongoDB supports big data. It is like this. Amazon is a cloud service provider. Google is a cloud service provider. Microsoft is a Google service provider. They are all coming, they are all implementing cloud computing. Hadoop implemented big data concept. There are many companies implemented big data concept. So big data is a concept. Big data is a term. Big data is an umbrella term. Big data is an enabler to handle different types of data. Right now you see, if I say I am having a big data system, that means it should support minimum of these characteristics. The first one, volume. I should be able to load so much of data, ingest, process and store very large data set. Do you think that you can put like 100 billions of data in your laptop? No way, right? So you need so much of a storage capacity, right? So you can put it in your laptop, you can put it in one single server. Do you think that we can put all the India, all the hospitals data, Indian hospitals data and all the healthcare data, everything in one database? No way. And velocity, speed of data generation, frequency of delivery, how quickly, the data is traffic signal. Every milliseconds or seconds, the data is generated. IoT signals, like say some madam was saying about EEG, right? So that is why we need a big data. Variety of data. Data is varying from different sources, from multiple sources. One person is saying, Ranganath is in the morning, he is saying, guys, very good morning, how you guys are doing, etc. Then, afternoon he is saying some different words, or he is speaking Sanskrit or, different language, or he is simply saying, just giving some messages, guys do this, or just all in the messages. It can be text, it can be audio, it can be video, with different variety of data. And variability. The data itself changes its shape. Like, the context is going to change. Ranga told, temperature changes. Now I am here, I'm using 500. Okay. And all suddenly that 500, I'm using it as a US dollar. Now the context is changed, the variability. The same currency has a different variability. If we go to a coffee shop, like say Starbucks or something, I'm having a coffee, but coffee with a different blend. The customer is having tell me some coffee blend, Ranga. Some nice coffee blend.
They can have cappuccino, they can have, South African blend, just a black coffee.
Okay. Indian filter, Kumbakonam degree filter. Yeah. Okay. So these are all right.
Yeah,
Excuse me.
all just the varieties. Even
Exactly.
different types. You walk into an ice cream shop, so there's so many different varieties of ice cream, right? That's
Yeah.
also one example.
Correct. And the data is going to change. Now, you may not think that customer will be always doing this 50. A customer probably changes that to 60 or 70, right? The value will be, changing, variety of, information. The data it's not going to be constant. That's all I'm trying to say. It is like this, very simple. I'm having a card with the ICICI. Using the card, I can do any type of transaction. That is simple as this, right? So I can go US also, I can use the card. Therein it is going to be billing with a different transaction. Maybe the amount 100, maybe less here, it is going to be more in US. So that capturing that variability and veracity, right? It has to be accurately it has to take, and then visualization. Somebody was talking about Tableau, right? So the data, whatever I'm doing, it has to be properly visualized. If I do all these things but I'm not able to visualize with the data, it doesn't make any sense. Then it has to give a right value to the business, right, customer. So with that, I have to make sense. So we will say a system is a big data system. A technology is a big data technology if the technology supports all these things. Same thing in the morning, we talked about cloud computing. We will say, I told you about standard, no? NSIT, National Institute of Standard and Technology, define how a cloud company should be. They have to implement these 5 characteristics, 3 services, 3, 4, 5, 4 deployment model, 5 characteristics. Similarly, if any company supporting these characteristics, they become big data, right? So data, it can be scaled up or scaled out. Okay. So for example, I'm trying to keep on adding on top of it. I know even like say Kumbhoram SASTRA campus, say 6th floor or 7th floor, or you take LIC 14th floor or anything, right? So you have to keep on adding it, and there is no way we can go, right? Rather, you put it in the parallel, horizontal scaling. That is the concept Hadoop has taken. Start distributing the data instead of loading vertically. Let us do horizontally. Distribute the data to multiple buses. Very simple example is the train, the goods that which carries from Mumbai to Chennai and Chennai to Kashmir, right? All those things, right? That is the horizontal scaling, right? You already seen how we can achieve big data by using virtualization. This morning in the cloud we talked about it, right? So we virtualize the server, we virtualize the disk, right? So there are 2 types of virtualization technology we use, type 1 and type 2. So if you see this type 1, take the full machine as virtualized machine, right? No intermediate operating system. You don't see anything intermediate. We just install VMware and then we virtualize the whole server. I can create 3 different operating system, not one single operating system, 3 different operating system running on one hypervisor, right? So that is the type 1, bare metal hypervisor. You see type 2, you have a box and you install an operating system. On top of that, you'll install the hypervisor and you provide the operating system. Classic example I've shown. What we are doing normally in our laptop or systems is a type 2 hypervisor, right? So everywhere we are going to use a virtual machine. Now coming to the core concept of big data. How big data is dealing with this amount of data? File systems, right? So they use the concept of distributed file system. Suppose if I look at my computer, I'm having a local file system. In olden days, we use something called network file system. See, for example, if I'll show you an example of network file system here. Yeah. So if you see here, you see that there are, do you see this? There is one RCDN 9, CO1, prod, MyGen 03. This is the remote host, and this is the file system. This file system is accessed from my local machine, right? So if I say like this, I can access it. So the file system can be a local. Okay, let me do like this. Suppose I am creating something, Venkat, and I can be there. This is under my system, right? And this also can be a remote system. See, this is local. The mount point is there here on this machine. Actually, if I really look at this guy, this users is mounted onto this machine. This is called a network file system. There is a concept, in a Windows we call it as a NTFS. In Unix we call it as a NFS and UFS, right? So that is what the initially everybody used it. Even now we are all using that file system. Now they changed that into a distributed file system, right? So your file system is not only in one machine. Here, as I shown you, this file system is only in this machine. But in Hadoop, in a distributed file system, these users will be in 5 machines. Like this prod MyGen 030, there will be MyGen 031, 032, 03, 5 different machines, 6 different machines. This one, if I go to users, and it is using the distributed file system of 200 servers, 300 servers. That is the distributed file system where we create the storage across network of machines. Are you clear with this concept first? File system, local file system, network file system versus distributed file system. Any doubt before I go further?
Please respond, participants. No doubts.
Very good.
One
See, file system, local file system, remote file system, network file system, we call, we are introducing the word called distributed file system and the distributed file. That is what Google has used. That is what Hadoop started using it. That is why we are able to support the big data. You can't support big data, no big data here, no big data here. Here also no big data. You can only connect to a few servers, that's all. Maximum we can support like 100 terabyte, not beyond that. So if I wanted to support 1,000 terabyte, where do I go? There is no machine is being built for supporting 1,000 terabyte. There is no storage capacity, one big disk available for 1,000 terabyte. Like say 10,000, let's go further. 10,000 terabyte or petabyte. No way. So you got to distribute the data. So that's where the so Google file system and Hadoop distributed file systems came into existence, right? So how do you design a distributed file system? How you write the data, read the data, right? So that's what they have done. What they have done was, because now we are talking about many machines, many servers, right? So hardware failures are most common because it's a commodity hardware, okay? And we have a files of larger size, and we have a lot of streaming inputs, sequential writes, and append. So once one file is written, it can be read many times. We don't want to change that, again and again change the file, but we can change the random modification. We can make it right, but that is not efficient Google file system. That's where that the Hadoop has started. Now we introduced a new word called Hadoop. Hadoop is introduced by Apache. It's an open source. Apache Hadoop or just Hadoop. It's a framework that allows for the distributed processing of large data. Corona data, the world corona data, India corona data, right? Corona patient data. That data is distributed. Corona is distributed, the data is distributed not in one machine, it is distributed in so many machines, right? So it is basically what technology we are using? Scale out storage and distributed by, in other words, horizontal storage, scale out, we go parallel, right? And that is the main thing, right? In the big data. So this is a history of Hadoop. I don't want to get there, right? So like how it works, one machine supporting 4 IO channels, each channel with 100 MB, one machine supporting 4 IO channels, each channel 100 MB, 4.3 minutes, reading 1 terabyte of data. So because the data is distributed, I'm getting faster reads from multiple environment, and that's where we use a map-reduce logic. I'm going to teach you that also. So Hadoop is reliable, scalable, flexible, economical, and this is the Hadoop architecture. So Hadoop uses, this is an older version, now we are going to 3. Hadoop 3 is coming, right? So we have a MR, MapReduce, for doing the batch processing to work with a different type of data. There is a data flow processing schemes. There is a Hive for supporting SQL. There is a RT, supports the streams, and there is a scheduler managing all the resources in big data. Again, this is not cloud. You will call this as a cloud when this whole thing is running on a cloud. That's all. Very simple. This is, you can have a Hadoop. Even I have set up 10-node cluster. That cluster can be local. It can be on a premises, or it can be on the cloud. This big data can be on the cloud also. The whole thing where you are setting up, based on that, it will change the name. Hadoop can run on the cloud. Basically the system, the Hadoop system, we have installed Hadoop and everything, that is going to be deployed on the cloud. That's all. So that is becoming a cloud, Hadoop cloud server. So Yarn is a yet another resource negotiator. What we do with the Yarn is, like say, there are many data, many machines. How we effectively handle all the nodes, that is handled by Yarn. But the basic concept is this: HDFS. This is the basic concept. On top of that, Hadoop is mouse pointer. Yeah, Hadoop distributed file system 2. That is what makes that, right? So there are a lot of other tools like HBase, Flume, Mahout, Pig, Hive, HBase, right? These are all some of the tools and things like that it can run. For quick inputs like this, you have a lot of libraries like packages we have in Python, Hadoop distributed file system. Yarn is another resource negotiator for scheduling the jobs, and this is very important. You need to know what is this HDFS, what is MapReduce. So it's a model to, how to store. How can I process the data? So we need a MapReduce. So Hadoop will support both HDFS and MapReduce, right? So which is written in a Java based on the Google GFS. So they use the Google GFS concept. They written the HDFS using Java, right? HDFS works best with a smaller number of Roger files, right? So the key concept I'm going to tell you, what we are doing here, take a file, the file is going to be split into blocks, so many blocks. You all studied in operating system, right? Suppose I have a 4 kilobytes of file, so I will make it as a 1K, 2K, 3K, 4K. So 4K block will be created. Blocks are split across many machines at a load time. I have split a file into 4 blocks. One block goes to one machine, second blocks go to second machine, third block go to third machine, so on and so forth, right? And the blocks are also replicated. One block, suppose one machine, suppose I am using the cluster, I set up a cluster using Revati machine, right? And Revati machine had some hard disk crash. What would happen? I'm going to lose the data. So that data block also to be replicated, right? So there is one concept called name node. The machines which you are using in the Hadoop environment are called data nodes. I'll use a notepad here. There are 2 nodes, data nodes and name node. Name node is like a super node. There can be one machine. That machine handles all the, suppose I am talking about 10 node cluster, big data cluster. That means I will have a 10 data nodes. These 10 data nodes can be 10 VMs, 10 physical machines, and physical servers, big servers also, and cloud images, whatever, right? And you can have one, if you're using image, and you have to go for image also, right? See, Please pay attention here. Now, there is the input file about, Venkat profile or Ranga's profile, or, some information, some transaction information, whatsoever it may be, right? So this data input file, how many blocks we have split? Ask them, Ranga. Are they giving answer?
Waiting. Ask the question one more time.
Yeah. So what do you see from this file? File is split into what?
Two people are saying file, one person, Dr. Parthivan saying 3.
Oh, really?
3 blocks. They're saying 3 blocks.
Really?
Sangamesh is saying 5.
Excellent. Sangamesh is perfectly correct because this file is split into 5 blocks. Block 1, block 2, block 3, block 4, block 5. This may be your objective, this may be your education, this may be your experience, this may be your certificate, this may be your personal details, etc. One biodata split into 5 blocks. What happened now? See this number 1, you are seeing 2, that's why you are seeing like this. Let me take 1 first. 1, where 1 is stored, how many blocks 1 is stored? Is it only stored in 1 block or it's stored in multiple places? How many places 1 is stored?
Jayapani is saying multiple, Revati is saying 1, rest are saying 3, Varsha is saying multiple.
Somebody saying 3, no? Who said 3?
Jayapandian, Dr. Valli Shri, Geeta, Varsha, Sangamesh, Jayapandian.
Excellent. That is a perfectly correct answer. See that the block 1 is stored in node B. It is also replicated in node C. It is also replicated in node E. This node B can be in Chennai. This node C can be in Bangalore. Node E can be in Mumbai. Or it can be in the same places also. Why we are doing it? Because in case of any problem, if this node is not accessible, still we can pull the data from node C. And also, why it is improving the performance? Because if I am there, very simple example, Ranganath is in Chennai, Venkat is in Chennai. Suppose, it is a profile of Venkat or Ranga, the Chennai server is near to us. This node is near to us. We can just read it. Cool, that's all. So because, it is giving you, instead of me accessing the Bangalore or Mumbai cloud, I am accessing it, right? So see the number 2. 2 is in node A, node B, node C. By default, Hadoop does 3-fold replica. You can change this configuration to 2 or 1, your choice. But normally, by default, a block, because we are dealing with a commodity machine. Are you clear with this concept of replication and how Hadoop works?
Yes.
Okay. So we use something called name node, and there are a lot of data nodes, right? So there are a lot of data nodes, and we know clients can read and write. Okay. And the metadata, the name node knows. Suppose Sankamesh is looking for some data, and name node knows which node has which block. It doesn't know full data, but it knows, like index. It knows, okay, Sangamesh is from Chennai or whatever, which location you are from, Sangamesh?
He said yesterday from that near Raghavendra Sthala.
Oh, okay. Let's say Raghavendra, Mandralayam, right?
Mandralayam.
Okay, let's say Mandralayam. So Mandralayam, and then it will look at that, what block you are accessing, and it knows, Mandralayam nearby is Mysore or Bangalore, I don't know which place. So accordingly, just go point to that data node. That is the power of name node, right?
Andhra. Mantralayam is Andhra.
Oh, thank you. Thank you. I didn't know. I thought it was in Karnataka. Karnataka border or something, isn't it?
Andhra.
Okay, thank you. I never been there. I went to Shirdi, I went to Sai Baba place, but not Mandralayam. I have to go. Okay, I told you about Hadoop distributed file system concept. That is very important for the big data. Similarly, there is one more concept called map, reduce. Map first, reduce next. Because we have lots of data, right? So yesterday, day before yesterday, Ranga talked about one format called JSON format. You remember? Key and value pair. It is neither platform or nor language specific, right? Wherever possible, each node processes the data that's stored on the node. We use this key value pair. So the data will be split into key and value pair, and we apply to the map reduce, right? So map phase, reduce phase. You will see further, you will understand. I'll give an example also. Suppose you saw the previous example, the file has been given. When the file has been given to the map reduce, what happened? Based on the type of data, how many data you have, it is going to read the file, start creating the map phase. Therein it is trying to convert that into a key value pair. Okay, and then it is going to combine the key value pair based on like a number of key value pair, the same key value, it aggregates it. And then it will shuffle based on the node, which node, and sort it. I'll show you an example, you'll understand. Then finally, we take the count. For example, I want to check Ranganath. How many Ranganath in India? So some Ranganath may be there in Tamil Nadu, some Ranganath may be in Andhra, some may be in Karnataka, some may be in Gujarat, we don't know. And other places it gives a zero count. So finally, I'm going to summarize the count and take it. That is where the reduced phase will work. And then finally output. Let's see an example. Are you able to see this input? Suppose there is a file. One file is being given. That file has deer, bear, river, car, river, deer, car, bear, right? So these many data. It's a simple example. Now imagine you are giving some data, like this is an example of map reduce for word count. They are trying to do the word count. There are a number of words are all there. They're trying to find out the word count. How many words are there? Checking the word count. So what we are doing is split the data into 3 blocks. Block 1 went to this node, data node. Block 2 went to node 2. Block 3 went to node 3. Are you clear so far? This process is called splitting. Ranga, check with them.
Yeah, they're saying yes.
Excellent. So I am not talking about the replication. It is assuming that it is duplicated into some other nodes. This data is there in some other place. I'm not talking about this. Is just showing an example of how the map reduce works. Now what we are doing is, what did we say? First, take the data, input it, map it, right? We are just going to convert into a key value pair, right? So we take the key and the value. That is what we are doing. But deer is 1, river is 1, bear is 1, right? So 1, 1, 1. So key is deer, and value is 1. Car is the key, value is 1. Car is 1. So we just have this. Are you clear with this step? Now what we are doing, we are just sorting and shuffling. We just did the sorting because now we are talking about word count. So start with B, C, D, R. Are you clear with that? And we also trying to, since how many words are there? Since how many words are there?
9, 9, 4, 9, 4.
No, the word.
How many words are there? He's asking. 4.
Deer and bear and river.
Car. 4 words, correct.
Excellent. Good job. So we take those 3 nodes, we add one more node, shuffle node. So what we are doing is we map and then we kind of split. We use this into node 1, node 2, node 3, node 4 because this is extra word and we put it as another node. This is called shuffling phase, right? Then we started summing up. This could be one data coming from Tamil Nadu, one data coming from Andhra. See, we just do all these things because the node 1 has river and node 2 has a river. See, this river 1 has come here. The river 1 has come here. You understand? So that is called shuffling and sorting. We do sorting. See the steps. Well, shuffling and sorting. Now we are doing the reduce. Reduce phase. We just count. This could be, for example, we have 1, 1. This could be million and million. Quickly, you have to see how the power of Hadoop. You do one word count of something, some input data, find out how many Michael is there. you'll be amazed. You'll see like a 15 million Michael in just like that, in a fraction of millisecond. That is the power of MapReduce. So we reduced it, and then finally we have it in the key value pair. Car is 3, deer is 2, deer is 2, river is 2, bear is 2. This is called MapReduce. Okay. So companies are using. Are you clear about MapReduce? I try to simplify as much as possible.
Yeah, they're saying yes.
Excellent. Thank you for nodding. And you can implement MapReduce using Python, using Java, using Python. You can do it through any language, no problem, right? So a lot of ways you can implement that, right? So with that, I'll quickly jump on to MongoDB. Now it is 2:47. Another 10 minutes, I'll be taking you through MongoDB. And I'll also show you, due to time, we also need to do the recap and review all the assignments. I'm not sure, like I'll be able to give a lot of demo, but I will try. Okay, there I'll show you online how you can access the MongoDB, and maybe we will have one dedicated session for MongoDB, like a 2 days or 3 days session. So because it is, I'll show you a simple example. I'll show you. Anga, are you seeing my different screen now?
Yes, yes.
Yeah. RDBMS versus NoSQL. You already seen, I already explained you. SQL is using some relational database structures. Data is stored as a tuple, and you have rows and columns, you have a lot of relationship, etc. In NoSQL, it's all key and value. Document has a link and structure. There will be a link ID for the document. You have a column stored. See, column stored. Not like going to be a row anymore. Each column is going to contain a data. The column store database. There is a graphical database. See, it's all here. What we do, the graph itself is stored inside as an image. Here you have a separate database. Graph can be separately stored. You can store a column store, rows converted into column here. You can store the documents. You can store the transaction key value pair. Right? Are you clear? Okay. One of the popular RDBMS, MySQL, MariaDB, Postgres, MS SQL, Oracle SQL, IBM DB2, SQLite, MS Access, Sybase, Informix, Postgres, it just goes on. Teradata, just goes on. NoSQL, MongoDB is one of the popular. Cassandra, CouchDB, Hypertable, Redis, React, Neo4j, Hadoop, HBase, RDB, Mongo has, AWS has DynamoDB. There are so many databases in the AWS platform, so you can check that, right? So on-premises versus cloud. Okay, so you can have it on your premises or you can have it in the cloud. If you have a big data system, you have your database, the database can be here or cloud. Same thing. I am putting a machine there to a cloud. That machine is running big data, that's all. That machine is running database, that's all. Right? So MongoDB provides scalability, flexibility, performance, right? So they compare the timing of this MongoDB. So NoSQL database called document database. It stores the data in the form of JSON-like document. It's highly scalable and flexible database. And see, this is the RDBMS. This is very important. Please pay attention. This is how we represent the data in regular databases. You come to MongoDB, NoSQL environment, unstructured environment. This is how we store. So this is going to be one data. This is going to be another data. First name. What is first name here? What is Joe? I want some answer.
Key, they are saying key. Joe is key value pairs, they are saying.
Excellent. Good job. So first name is key, Bob is a value, last name is a key. It's because of the green color you're not seeing it. It's an email address only. bob@abc.in. Okay. So this is how MongoDB stores the data, right? So this is comparing. We'll just go. Where to use MongoDB? When I wanted to deal with the big data, then I'll use MongoDB. When I want to manage the content, so many contents, so many words, so many images and things like that, I'll use this. When I want to use the mobile, I can use. There is a mobile version is there. Use a data management. You can make it as a data hub or data lake. Okay, to work with Mongo, now you can take a paper and pen, note down these commands. Take a paper and pen, note down the command. I am using the Mongo Atlas campus community. Okay, there are, before I go further, I want to tell you one concept here. This is my MongoDB connection, MongoDB cluster. This is in the cloud. So I can make a connection to the Mongo running on the cluster. Okay, so let me minimize this, I'll come back. So if you are talking about the databases, right? Suppose what are the ways we have been studying about so much of data, right? So data can be stored in XLS file. All of you know, right? Yes or no? And you can save it in a CSV file, comma separated values. You can save it in a JSON format, or you can save it in some database, right? Or the data can be stored in the cloud. Remember when we shown some examples, we have shown you like how from Python the data set. And also you can define the data within the code. Are you clear so far? Right? Within the code itself, we can define the data, or you can load the data from the XLS file, CSV, JSON, or XML file, right? But when it comes to
yes.
Thank you. When it comes to database, there are three ways you can access a database. Suppose you have, whether it is MongoDB or Oracle or MySQL or whatever database may be, a database having some table and data, you need to connect. Without connection, it's not a magic. It is not like, whatever I say, hey, come on, give me the data. No, I have to do something. So there is something called shell-based connection, or it is called shared memory-based connection. That means you install and then you can use basically command line mode, or I have to install the drivers. Like say, let me try to show my video on. Where is my mobile? Okay, so how do I connect this mobile to this laptop? What do I need? What do I need? Forget about Bluetooth, assuming that, oh no, I want the answer later USB. Forget about my phone is no Wi-Fi, my laptop doesn't support Wi-Fi, my laptop doesn't support Bluetooth. But minimum my laptop support USB. Excellent, excellent. If I give my phone to Professor Vikas Dubey, can he copy some of the files from my phone to his laptop or not by using USB? OTG, yes, yes. How it is possible? How it is possible? What is that doing the trick? Anybody knows? When you connected your camera to your laptop, some sound will come. Have you noticed that? Any device you connect, what is it? Actually, it is trying to do something. What is it? It is trying to install. It is doing something. I want to answer. Who is that? Dr. H.L. Thacker. Hats on. Hats off to you. Excellent. Excellent.
Krishnakant also says drivers. Yeah.
Excellent. Wonderful. See that? Now, if I go to my PC and then if I go and look at the control panel or configuration, config. Okay, system configuration and the drivers. I can see lots and lots of drivers, and then drivers. Yeah, devices manager. Right. So if we go there, there are a lot of drivers are there. You see this Bluetooth, right? All these things. I just go to the USB, right? So I have this USB controller, right? And it has some USB device and support, and there are some drivers softwares available, right? So if you go there, if you click going further and further, you will see the driver software is installed, right? For this particular USB root hub, there is a driver detail. Look at the driver detail. Where is this driver? This is system file, USB hub. So it's not a rocket science, not a magic. They have a system file. That system file is a system call will be made. As soon as you connect your mobile, as soon as you connect your device, this driver software will invoke and then makes a connection. It's very simple. It is using this in the system programming, in the system software, we use a concept called yeah. So we use something called system programs, right? So we do make a lot of system calls. So first call will be opening, collecting. You have to collect, right? Whatever I'm saying is very important. I'm just taking you to the the big step. This is common, right? So then you will start reading data, writing data, appending data, and then you can close. So we call it as an open system call, read system call, write system call, close system call. These are all some of the system calls, right? The same principle also used in the database. The database can be Mongo, Oracle, MySQL, whatever it is, you need to have a driver. Either you connect shell using some the networking environment, locally you are connecting, or using the shell you are connecting, or using the driver you are connecting it. And using the driver, like say from Python, you have to look at Python Mongo. If you want to work with Python and Mongo, just Google it, Python Mongo DB driver. You got to install MongoDB and Python. You have to install the PyMongo library. How to install PyMongo library, and I will share this in your this one. I will share this in the chat window. There is a chat window. Are you seeing my screen, Ranga?
Yeah.
I shared this. You can kindly copy and paste. See, this is like sudo Python. You can install in pip. You all know pip, right? Pip install PyMongo. What I'm saying is, without the driver, you cannot connect to the database, or you use that cloud-based connection. Once you have this driver, you can work. Similarly, if you want to work with MongoDB, okay, like say Python, okay, drivers for Oracle connection, okay, for Python. So you will have drivers, right? They will be giving you the Oracle driver, right? So if you go to your system, there is something called ODBC. You go to ODBC, I've already configured some driver. I'll show you. See, are you seeing it? I have one GISDB set up. So if I go and click this GISDB, this is using on MySQL driver. So if I just go and test, it will connect. Oh, this connect failed. True. What's the password? Maybe I have not started the database. I did not start the database. So it has the port number, user ID, password. So that's all I'm trying to tell you, to work with the any database, because I'm giving all these details because there's a mixed background. Some people are from mechanical, some people are from ECE. That's why I'm going into this much of detail. Some people are having statistics background, right? management. So you need to have a driver. There are like ODBC drivers, JDBC drivers. Okay, right. So you can use shell, you can use a driver, or you can directly connect to a cloud using the specific tool given by the vendor. Vendor will give you a specific tool given by the vendor, right? They will also give you a web service, right? Because we are talking about cloud. No, if it is cloud, then you have to use web service only, right? So having said that, let's look at this. First, quickly I go through and see, if I want to get into a Mongo, you have to type Mongo. After you install your Mongo, then you have to type Mongo. Mongo can be, how to use a MongoDB? MongoDB is available on Windows, on Linux. You can just, Linux means it's a tar file you'll have. Windows means you'll have a zip file. You just set up, very easy to use. Then type Mongo. You can work with the Mongo, right? And then you can also use the cloud-based Mongo. There is a Mongo cloud is available that is called Mongo Atlas. Okay, I'm going to show you that. It will show DBS. It will show list of all databases. We say DB, display all the active database name, which database I'm currently connected. db.stats, it shows the database name, number of connections, how many collections are all there. In here, we are calling everything as a collection and documents. In RDBMS, we call it as a table and record. Here we call it as a collection and document. If you say use DB underscore name, suppose use Revati DB, Ranga DB, then it will switch it to that database. DB.drop, you can drop the database, right? See this? How to create a collection, a simple collection. Did I specify any data type here? No need. It will like Python. You know, did we do any type specification in Python? I want to see yes or no. Did I ever, Ranga or myself, Ranga has used lot of string code, numbers and all. I also did lot of numbers and mean and other thing. Did I ever say it is an integer, character, blah, 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 float? Did we ever say the data types? I want some answers.
Depending upon value, variable type is defined. Dynamic type.
But we did not declare.
We did not declare, correct. We did not
That's
declare.
all I'm trying to tell you. See, if you go to this, Oracle and all those things, you know, we define the types. We say, let me show.
Correct, it's 305.
Yeah. I'll go fast. Just hold on. I know. I got it. Table creation. That's I want to show them. Table creation and query. Anyway, so here we don't specify any data type. We have to create a table and then give the data types, names, etc. Right here, we don't specify any type. Okay. We just say db.create collection name comma options. So it will create the collection. And you know, db.create collection, I can simply say employees. It will create one data. That's all. I did not say I can just drop the collection. If I want to insert, I can insert the data. If I want to find the data, in Oracle we use where clause. Here we use find. This is a database, find, right? This is equal to where equal to tutorials by. Here it is like, you know, by is tutorial point. It's pretty, right? This is how we link the table, name and data, right? So, and if you want to work with Python, as Python and MongoDB together, there is something called MongoDB. Its connection is closed. Okay, I have to start the cluster. Let me start the cluster. You all have to do. I don't think I will be able to give a demo due to the timeline. We need to review the assignments also. I will tell you MongoDB cluster. MongoDB cloud. All of you take this link, MongoDB cloud link, what you need to do is, you can just, I will show you step-by-step instruction. You can just go try free. It's so easy. Try free. And then this is cloud on-premises tools available. We wanted to go with a cloud-based solution. I don't want to have anywhere I wanted to access. So you can go with the cloud-based. You need to log in with your Google ID or whatever. And then I've already logged in. It's coming. I'm already having an account. So when you log in, you can give your email address or log in with a Google account. Okay, you can create one account in MongoDB, or you can log in with Google. So suppose I'm using my, a Gmail and logging in, and then it will allow you to create one cluster, and you will be getting a prompt, and then you can just use it. Okay, so I think that is. I will send some instructions here. See, I told you what is that? I already have one cluster. The cluster, you can create a cluster. Suppose if you want to create, you can create a cluster because it is using the cloud resources. You can create a cluster. You can create your own cluster. Okay, so what is that you want? AWS based, or what cluster you want, and you want a free cluster. Like Vijay Bharat shown, no, you can use a free cluster, and then you can choose Mumbai. I think Mumbai will be somewhere here. Yeah, Mumbai free trial available. Okay, so you can click that and you just create a cluster, and country you just select. Then you will create a cluster. Once your cluster is created, and you can access the cluster. So that's the way you work with the MongoDB. I will send you some step-by-step instructions for all of you. Okay, that will be helpful for you. Due to the timeline, I'm unable to go through this, but maybe God wishes, time permits, I will definitely prepare one screen snapshot for all of you, and then you should be able to work with that. Because if I go there and it will take another 1 hour, 1.5 hours. So we should complete the review and feedback and other things. Okay, with that it is 3:09. We can take a break, or we do a recap quickly. How much minutes we have, Sudha ma'am, when we can have a break?
Break, if you want, we can just break for 10 minutes now. Let's get back at 3:20. 5 minutes, yeah, we'll get back at 3:15, 3:16.
Yeah, please be back by 3:15 p.m. Okay, when you come back, we will do a quick recap of what has been discussed quickly, and then we will also. There are a lot of people. Sudha ma'am, have you seen that all the assignments have submitted?
Yes,
Madam has mailed, yes.
Excellent. So we will load it. We'll start with Krishnakanta. Okay, Krishnakanta submitted first. I saw him, so he will be presenting first, and then we will go for the review. Okay, so please come back by another 5 minutes. So 3:15 p.m. Okay. Thank you very much. I'll have my coffee or tea. I need to have some energy. Ma'am, Sudha ma'am, you can turn up the video, pause the recording. Thank you.
Thank you.